through the second one together. This looks pretty complicated because there's a lot. All right, in dominoes, represents top and bottom halves of the ith domino. Okay, so I guess like this. A domino is a tile with two numbers from 1 to 6, one on each half of the tile. So one domino is one column, I guess. We may rotate the ith domino so that the top and bottom swap value. Return the minimum number of rotations so that all the values in the top are the same. Or all the values in the bottom are the same. If this can't be done, return -1. Okay. And it's 1 to 6. So let's see. The first question is, how do I know it's 2, for example? And here it's like, well, how do I know it's 3? Tricky, eh? So I guess the thing in interviews, it's like, if you're just thinking and then the interview is like, what are you doing? Then it's like, they're also interrupting your thought process. So it's like, it's easy for me to pause here, but it's like not as easy to pause in an actual interview. So I guess, yeah, I mean, the good thing with dominoes is that there's really only 2. And if they don't deliver in 30 minutes, it's free. But in this case, there's only 2 dominoes. So if I start at a 2, so there's kind of 2 checks, right? If I assume that 2 is the number that I'm going to do, then what I can do is just run through the array and then say, well, all right, is top and bottom are either of these 2? If yes, then I need to first see, well, it is the top 2, right? If the top isn't 2, then I add 1 to a rotation. And then same thing here, right? If either one of these 2 are 2, that's great. But if top is 2, then I don't add 1 to the rotation. But I guess, yeah, and then I kind of keep going on. And then so if there's a chain breaker, right, like neither of these are 2, then I just break out of it and say, well, okay, for the top it is impossible, and symmetric argument on the bottom side. Now, the thing is, what if this was 5-2? And, well, I guess if this was 5-2, then it's okay, actually, yeah. If this is 5-2, it's also fine. Because then the 2 check would be, I was just afraid I would be off by 1 in the flip, but the thing is, it's like pretty much symmetric. Because then you would just check like, okay, well, this one, no flip, this one, flip, no flip, flip, no flip, and then you're good. And then on this one, it'd be a 5. And because there's only 2, there's no like optimal configuration where it's like, if like you won't have less switches if like the bottom and tops were reversed, for example, because you're just trying to collapse it into one thing anyway. So I think like if this was flipped, then you could do like, oh, I flipped this 1, 2, and 3 to do it, or you can flip 1 and 2 to do it. I see. So it is not symmetric. And then what if you have like, well, if both 2 and 5 can do it, then it'll end up with the same answer. But yeah, if this is 5 and 2, for example, you can flip the first one first, and 1, 2, 3. And if this is 5 and 2, you can just flip, 1, 2. But that, yeah, because if it's 5 and 2, and then let's say all of these were 2s at the top here, and it's like 5 and 2, then my algorithm would say like, oh, you have to do 5 minimum, but you could have easily just done it, if you swapped. So it's almost like 4 passes. It's what I described, right? You start with this, and then you do this. You kind of just scan it across, across all eyes, and then you count it. And then it's like, oh, it's like 2 for the top. And then and obviously if there's no, like if neither are 2 for any particular eye, you break out of it, and then you're good, because it doesn't matter if you switch the orientation. The 2 would still be missing somewhere down the line. And then then you try the same thing, except you pretend that the top is at the bottom, and then you do like 1, 2, and then you count yourself. It's like 3. So if you pretend at bottom, you add 1 to the number of flips, and then you kind of try to see if that is less than your top. And then if yes, then you're good. And then if the top returns like, if the top doesn't have anything, then you work on the bottom with the same principle. And if the top has some optimal solution, do you need to check the bottom? Because the bottom, like, if these are all like 2s and 5s, and you have some optimal solution for one of these, then it seems like it should just be symmetric. Because no matter what, in the case where it's like, let's say all the top were 2s, all the tops were 5s and the bottom were 2s, and you flip them, it's 1. Yeah, or if you're trying to optimize for the bottom, and then all the tops are 5s, all the bottoms are 2, you'd be able to, like, instead of 5 in the second iteration on the bottom, then you'd be able to find it. So it doesn't seem like, so if everything was guaranteed to have 2s and 5s, can we make the statement that finding the optimal solutions tops enough? Yeah, I would say yeah, because there's only 2, and then there's kind of nowhere else for the 2 and 5 to go, for example. So yeah, stared at that for a while. So I guess the algorithm is basically check twice for top, and then if top doesn't actually have anything, go to the bottom and check twice for bottom. So it's top size, bottom eye. So number of switches is 0, so then I actually want to start at 1, because we're starting at like 0. So So later on when I check the bottom, and let's say this is false and then the bottom's also false, no, actually, yeah, it doesn't matter. If the bottom has no solution, we return -1, but if the top has no solution, we check the bottom. But if we don't find anything, it's enough to say the top doesn't have anything. Right. This means, else means either top or bottom has this 2, for example. Then what I want to do, then I want to say if bottom's I is my top, then num switches equals 1. So if it's not at the bottom, it's at the top because of this statement here, right? Actually, that's not true, because this, if both were 2, then this gets screwed up, right? So actually top's I equals my top, then I don't do anything, then, you know, continue. Otherwise the top isn't it, so let's check the bottom. So we're going optimistic, so like if the top is already a 2, then we don't need to check anything, we just keep going, there's no switches required, and then on the bottom we say, okay, on the bottom we say, okay, we've checked the top and we know the bottom to, you know, definitely be 2 because of this check, right? Because if it's not at the top, you know, it must have been at the bottom, otherwise we wouldn't have fell into this else statement, and therefore num switches plus equals 1. And then, cool. So now, I want to do this multiple times with various factors. So yeah. So since I want to do this up to 4 times, I don't really want to copy paste it a bunch of times. So let's do tops, bottoms, and then init num switches, we replace this, because if we switch it, then like we want to start with this instead. And then your tops is still, you know, this tops. Position is top or bottom. So for example, and then here position will just be a string of top or bottom. So if position equals top, then so instead of my top, I'll do my position. just tops, and then my array, I'll just do a reference to the tops. Else, if position equals bottom, my so this algorithm would just look at the bottoms. So my position is the head of the first, like the beginning of the tops or bottoms array, and then my array will just be tops or bottoms correspondingly. But actually, yeah, it's my array and my other array, right? So my other array is bottoms, and then my other array is tops. Probably need to initialize these. My position is, let's say, 0, and then my other array. Okay. So then we can say, okay, this says my array is bottoms, is my other array. Then here, if I'm tops, and this is my array. So basically, I'm saying, well, I'm top or bottom, and my other word is top bottom, and my position is just like the thing I'm checking against. And if it doesn't exist, this breaks, but actually I need to return something. Figure out what. But if it is something I can detect, then my array equals my position, which means that I'm not doing a flip, so just continue. Otherwise, num switches plus equals 1. And now I just return the num switches, basically, normally. Or I return a special value, so perhaps I can return a -1. And then num doms I use here, but I could actually just say, do it like this. So then I can actually just say like min, or like check dominoes, tops, bottoms, just a pass through, and then initially I'll do 0 for the non-switched. But if I am switched, this is a little bit different, because if I'm switched, then so this is for this case, but then else if my other array so this needs this qualifier, because if I am switched, I actually want to check. So if 5 and 2 is switch, I'm actually checking against the bottom to not have switches. Otherwise, I'll need to flip it, yeah. And num switches plus equals 1. So in either case, if I do a num switches of 1, then this initial condition is changed, and well, this doesn't change because I'm still, disqualifying the entire thing if neither 5 or 2 exists. But then if my initial position is actually on the bottom, then I actually want to check this other array to see if my position's here. And if it is, I continue. If not, then by this, I guess, anti-disqualifier, then it implies that the other one is the 2, and therefore I would plus equals 1. And then here I also need to return num switches, and yeah. Okay, so tops, bottoms, minus switches, and then my position, you know, top. So you have top, bottoms, init, num switches is 1. Then I would check this my other array, yeah, which is the bottoms. Okay. I actually want to run this real quick and see what the printout is. If you want to optimize it, you can say, if this is not -1, but whatever. And then let me do bot non-switch. So if I'm bottom and I switched, I still start with this 5, which is okay. I switched by 1, and then let's see. Okay. So if so the only way you're gonna for it is if they're all -1, because if something's found, it will be a 0 or more situation. So if this is -4, return -1, right? Else return yeah, I can't say the minimum because if it's the minimum, then it's always -1. I guess it's kind of brute force, but is something? Yeah, it is. So maybe I can just do this results. Otherwise, for R in results, I'll just do like a manual minimum. Two times 10 to the 4, so this is probably more insufficient. This is just to make the -1 saturate, so then I can just return min of results. Okay, let's try. I don't know. Oh, nice. I actually did it. Oh, I guess this was supposed to be easy, but okay. I'm generating my report. This typically takes less than a minute. Let's see what score I get. I might wait a tiny bit. Okay, that was pretty terrible. I guess most people take, it doesn't really tell you how long people take. All right. So yeah. All right, I beat 38% of people, so pretty good. And on that disappointing note, goodbye.